So in this video, we'll continue our discussion of some of the problems from SAT practice test number 8, section 3. So that's the non-calculator math section. And in the question that we'll start off with within this video, they present us with two inequalities. So y is greater than 2x minus 1, and then 2x is greater than 5. Which of the following consists of the y coordinates of all points that satisfy the system of inequalities above? So what I recognized about the inequality underlined in red here is I could isolate the x within that inequality pretty easily, just divide both sides by 2, and that turns into x is greater than 2.5. Now, my personal preference here, when I see a set of inequalities where both variables x and y are involved, I'm going to want to graph that in the coordinate plane. So what I did is, we'll go with the red one first since that's what we're looking at right here. I graphed the boundary x equals 2.5, which is this vertical line. I made it dashed since I don't have the equal to portion on this inequality, and then I realized that all of the x's above 2.5 were to the right, so I shaded everything to the right. In blue, I graphed the other inequalities. So to graph the boundary y equals 2x minus 1, I'm going to start with a y-intercept of -1. I'm going to do a rise of 2, run of 1, rise of 2, run of 1. I made that boundary dashed as well, since the equal to part wasn't within that inequality either. And then the y's that are greater than 2x minus 1, if you test any ordered pairs, you're going to realize that the y's that work are up here, shaded in blue. Now, the solution to the system of inequalities is where the overlap happens. The overlap is up in this little wedge right here, so I don't really have much of it shown based on the graph that I've made, but you hopefully can clearly see that's where the overlap is. Now look at these options. We want to try to figure out which of these that involves only y is going to represent the solution set to this. Well, let's see. Looks like all the y's are above this point right here. So if I can figure out what the y right here is, y would have to be greater than this location in order to be part of the portion that's shaded in green. So I realized that that's the intersection of the two boundaries. So if I just put the x value of 2.5 into the equation that you would be able to get from the top inequality, what you end up determining is the y coordinate of that intersection. After doing this quick calculation here, is you end up with 4. So all of the y's that are shaded in the overlapping region in green are y's that are greater than 4. This next question is one that's a little more involved than you might first think. We're asked to solve the equation. So, okay, let's try to isolate x. So what I realize is that there's x's on both sides of this, and that's going to present a little bit of an issue. One thing that I notice is the root. I don't want to have x's under roots. I would prefer if that root were gone. One mistake that I would think would be pretty common here would be just to try to square both sides of the equation right away, and that's not necessarily incorrect to do, but it's not really that beneficial of a step to do, because if you square this left-hand side of the equation, what you're going to have to do when you square that side is you're going to have to FOIL out this set of parentheses times itself a second time. You're going to have to expand that, and that's going to, get rid of the root when you multiply first and first together, but it's still going to leave you with that same root when you do outer and inner. So rather than doing that as the initial step, I chose to isolate the root, so I subtracted 4 from both sides, and then I got rid of it. Whenever I have the root isolated on the left-hand side, when I square the root goes away. So that was nice and convenient for the left-hand side. Now here's what that means about the right-hand side. I did have to subtract 4 from the 3, so that gives me a -1. I'd be worried about this mistake as well. Whenever we have a set of parentheses being squared, you cannot distribute an exponent into the parentheses. In other words, if there's addition or subtraction as the operation within the parentheses, you're going to have to expand that. So I actually came over here to do that expansion. Now I kind of mentioned this about the first step that I was initially suggesting. Whenever I have a set of parentheses squared, that's really the set of parentheses times itself, and if I expand this, this is going to be the answer I get. So x squared minus 2x plus 1 is what that right-hand side is going to simplify to. All right, well, let's get all of our x's onto one side here. So I'm going to subtract 2x from both sides so that those go away. I'm going to subtract 6 from both sides. Now, the reason why I also moved the 6 over is because what I recognized was that this was going to be a quadratic equation. And when you solve a quadratic equation, you've got some options for how you choose to solve it. You can solve with the quadratic formula. You can solve with completing the square. Sometimes you can solve by factoring. A little hint about non-calculator questions, whether they're on the SAT or maybe in a calculus or a pre-calculus class. If you have to solve a quadratic equation without a calculator, it's not going to be 100% of the time, but I would say well over 90% of the time, it's going to be something that you can solve by factoring. So after you get that left-hand side set equal to 0, you can turn around and try to factor the right-hand side. So you would want to have first times first giving you x squared. You would want last times last giving you -5. And then you would want the outer multiplication and the inner multiplication from FOIL giving you the -4x that you see in the middle. Once you've gotten the right-hand side factored, the only way that a multiplication problem can have a result of 0 is if either this piece of the multiplication problem or this piece of the multiplication problem is equal to 0. So we set each piece equal to 0, we solve those simple equations, and we get two solutions, 5 and -1, and that is, of course, option C. The next question here gives us f of x and g of x, and then they ask us to try to decide which of the following expressions is equivalent to this for x is above 3. Now, f of x divided by g of x is pretty easy to compute, right? It's going to look like this. And you say, well, what's the big deal here? F of x divided by g of x. It's right there. You look at the options, and none of the options match with this fraction right here. So there's obviously going to be a little bit more that goes into this. Now, if you look at all of these options, particularly those bottom two options, notice how the numerator of each of those is factored. The numerator of option C has multiplication between the x and that set of parentheses, and option D has the same. So when you have a polynomial divided by a polynomial, you can simplify it with either long division of polynomials, synthetic division of polynomials, but you heard me say a little bit about factoring in the last problem. When you're dealing with quadratic expressions, when you're dealing with polynomials and no calculators involved, the majority of the time you will be able to develop your results by factoring. And so what I recognized about the numerator here when I went to factor it, there was a common factor of x shared by both terms, so I basically undistributed that common factor of x. And then I recognized this as a difference of squares. X squared minus 9 is going to factor to x plus 3 times x minus 3. Now in the denominator, I factored that as well, very similarly to how we finished up the prior problem, and that left me with what you see right here. Once you have the numerator written as multiplication, and across this line that's exactly what we have, and the denominator written as multiplication, at that point what you can do is you can cancel common factors. So this x minus 3 and this x minus 3, those are going to cancel, and that's going to leave us with, I believe, we're looking at option D. One thing that I probably should have said about 2 minutes ago is one thing that I would be worried about happening. Now, this is a multiple choice question, and you don't have one of the answers arise from doing what I'm about to do, but I see this mistake all the time. Cancel this x with that x, right? There's an x in the numerator, there's an x in the denominator. The reason why you can't do the sort of cancellation that I just suggested, I violate the order of operations. There's really parentheses around that subtraction in the numerator, and there's really parentheses here. I can't reach into the parentheses and do this division with those x's. Once I get the numerator and denominator to be written as multiplication, because multiplication and division are essentially tied together within the order of operations, that's what gives us the flexibility to cancel those common factors. If you look at number 9 here, number 9 is a pretty tricky question. They tell us that if we graph this equation, we get a circle. So the general form for the equation of a circle in the coordinate plane is this right here. The center of the circle would be h comma k. What you have to watch out for is you do notice subtraction. So the subtraction here in front of the h does not indicate the sign of the x coordinate of the center, right? We have positive h for the x coordinate of the center. We have positive k for the y coordinate of the center. And then the number that's over here, that is not the radius, that is the radius squared. And so if I think about how I can apply that concept to this equation, the center of my circle would be positive 6 for the x coordinate and -5 for the y-coordinate. So you see I came over positive 6 units in the x direction, down 5 units in the y direction. And then the radius of this circle, well, this is r squared, therefore my radius is going to be the square root of 16, which is 4. So what I did is I just went up 4 units from that center, down 4 units from that center, to the right 4 units, and to the left 4 units, and that gave me the graph of that circle. Now, if we look a little further, it tells us the point P is on the circle and has coordinates 10, -5. Well, if I go over from 6, -5, 4 units to the right, I do get to that exact set of coordinates, 10, -5. They say PQ is the diameter of the circle, and they tell us that P is really this point right here, 10, -5. So that's point P. So point Q, since they say PQ is a diameter, goes through the center and hits the circle on the other side. So basically we're looking for this other point that we used to help build our circle graph a few minutes ago. And so if I was at the center and I came to the left 1, 2, 3, 4 units, the x-coordinate would be going from +6 down to +2, and that would be the other coordinate that we're looking for, that diameter. And then the last question that we'll talk about here is a little story problem here. You've probably done questions like this. It's a pretty popular type of question to pop up in Algebra 1 and Algebra 2 class. They tell us we've got a group of 202 people. They go on an overnight camping trip. They have 60 tents. Some of the tents held 2 people. Some of them had the rest held 4 people. Assuming all the tents were filled to capacity and every person got to sleep in a tent, exactly how many of the tents were 2-person tents? So what I think is, well, the two things that I don't know here are the number of 2-person tents and the number of 4-person tents. So I just picked X for the number of 2-person tents and Y for the number of 4-person tents. I know the total number of tents that they take is 60. So if I add X and Y together, I have to get up to 60 tents. And I know the total number of people on this trip are 202. So I know 2 people fit in each X and 4 people fit in each Y. So 2x plus 4y has to equal 202. So we've got this system of equations here. It doesn't matter how you solve it. I guess you can't solve by graphing on the calculator. Calculator's not in play for this question, but what you can do is you can solve by substitution. You can solve by elimination. I thought it was not going to be too bad to solve this by elimination, because what I can do is I can multiply this top equation by 4, and I multiplied it by 4 rather than 2 because what I really want here is I want x. It's a little easier to multiply this top equation by 2 and get there to be a 2x and a 2x in the new form of one of the equations and the original form of the other. I'm looking for x, so I don't want to eliminate x. So with that in mind, I would like there to be matching coefficients in front of the variable y, and I can do that by multiplying this top equation by 4. So there'll be a 4x plus 4y equals 240. And if I subtract 4y and 4y, that gives me 0y. So I'm going to subtract the original form of the second equation from the new form of the top equation. 4x minus 2x gives me 2x. My y's go away. They're eliminated. 240 minus 202 gives me 38. If I divide both sides of that equation by 2, 38 divided by 2 is going to give me an answer of 19.